Welcome back, everybody. This video is going to cover sine and cosine graphs, which are known as sinusoids. And what we're going to do is show you how you can graph a sine wave, tying it into the unit circle. So a couple of key points you need to know about the unit circle is the fact that the radius is always 1. So all of our coordinates at your x and y axis are going to be 1, 0, 0, 1, and a whole bunch of stuff in between, as we know, is the square root of 3 over 3, or the square root of 3 over 2, and the square root of 2 over 2, and 1/2. We have all those values in between, and then, of course, things that are even in between that. So we're going to start with sine, and the first thing we're going to do is just ask you, what is the sine of 0? Well, sine is y, so the sine of 0 is 0. And what if we're going to talk about the sine of pi over 2? The sine of pi over 2 is 1. So the sine of pi over 2 is 1. What is the sine of pi? It would be negative, or it would be 0. What's the sine of 3 pi over 2? We see that 3 pi over 2 is a negative 1. And finally, once we go all the way back to 2 pi, which is also 0, we're back at where we originally started, and that's known as one cycle of a sine wave. Okay, so when you complete one cycle, it's going to start repeating the pattern. So if this were to continue, that exact same pattern would exist that we started with. Okay, now let's go backwards. So if we're sitting right at 0 again, we're still at 0, but let's go to negative 90 or negative pi over 2. We're at negative 1. So if you continue the pattern, it will go both ways. What if we're at negative pi? We're back at 0. What if we're at negative 3 pi over 2? We're back up at 1. And obviously, negative 2 pi will bring us back to the beginning. So this is 2 cycles of a sine wave. And of course, the pattern would continue, and it's just going to repeat itself over and over and over again. That is what a sine wave looks like. Now, cosine waves are also known as sinusoids because they look the same, they're just shifted a little bit differently. And to be honest, once we start writing equations, you could actually pick sine or cosine to make it happen. So what does the cosine of x look like? So remember, cosine is the x value. So what's the cosine of 0? We actually start up at 1. What's the cosine of pi over 2? X value is 0. What's the cosine of pi? We're now at negative 1. What's the cosine of 3 pi over 2? We're back at 0. And finally, if we're at the cosine of 2 pi, which is the same as our starting point, we're back at 1. And this is what a cosine wave looks like. Looks pretty much exactly as the sine wave, except for it's just been shifted over a little bit. And that's because the cosine of 0 is 1 instead of 0. So this just got shifted over just a little bit. And of course, we could go through the whole motion, but it will follow the exact same pattern going backwards. So if we were to continue this, so that's 2 cycles of a sine and a cosine wave, just so you can see them, okay? And that's what we're going to be working with. So, of course, we have transformations with sine and cosine waves. There are actually 4 of them, and we are going to cover all 4 of them right now. And some of them are very similar. So we still have the A. B is the only thing that's different that you're not familiar with. For C and D, this could actually be written as A, and then whatever your trig value is, sine or cosine of B, and then you'd be more familiar with x minus h plus k, because the C and D are your horizontal shift and your vertical shift. So either one of those are the same, but some places you'll see A, B, C, and D instead of A, B, H, and K. So just wanted to give you a heads up. So the A value is technically still your vertical shift, or vertical stretch is what I'm trying to say, or compress. If it was negative, it would still be upside down or flipped over the x-axis. So the cosine of x. Now, I'm just going to quickly sketch out what we saw the cosine of x to be. And it started up high, and it looked like that. And I'll just kind of sketch it out so you can see it. This is the parent graph. So what does the 2 do? It's the amplitude, which is also known as the vertical stretch. So what it means is your amplitude is now 2. So a really good way to do these questions are to think about where your top and bottom is. Well, you got to know where your center line is, which is known as the node. That would be our x-axis. But then you have what's your top and bottom. They're known as the crest and trough, but that's how far up and down you go. So now everything's just been multiplied or vertically stretched by 2. So now 0 is actually going to start at 2. And once you get to pi over 2, that's still going to be at the first tick mark. And then we're going to be at -2 instead of -1. So really the only thing that's happening here is we're going to go to a vertical stretch of 2. And our graph would look like this. Done. Now the last thing we should talk about is your tick marks. Sine and cosine always start to repeat themselves at pi. So your fourth tick mark is always going to be 2 pi. And then, of course, what you want to do is divide your period by your b value. That'll give you your new one. And then what we're going to do is divide that by 4. That's your interval. So 2 pi over 4 would be pi over 2. That's why our first tick mark is pi over 2. This guy is 2 pi over 2, which we know is just pi. And this guy is 3 pi over 2. And then, of course, 4 pi over 2. That's how we can sketch out our intervals. And we're going to show you how that changes in the very near future. Okay? So the next example. The next example is a sine value. So I'm just going to, again, quickly sketch out what the parent function would look like, as we already talked about at the top. Since we don't have any change in our period, we're going to label the tick marks the same. So this would be pi over 2, this would be pi, this would be 3 pi over 2, and this would be 2 pi. Okay? So, and of course it's going to go backwards in the same direction. Now this example has a vertical shift of 1 down. So what that does is that takes your center line, as I mentioned is called a node. It shifts the entire graph down 1. And then of course our amplitude is 1. There's no stretching vertically. Each one of these examples I show you today in this video is going to be with one transformation. The next video will show you multi-step. So basically what happened is we shifted everything down 1. So the trick is you have to remember sine always starts on the node. And if it's positive, it's just going to go up. So it's going to go up 1, back down to the node. Down to the bottom, back to the node. Going in the backwards direction, we follow the pattern. We're now going down to the bottom, at the node, up to the top, back to the node. You will always hit the node line or your center line before you hit the top or bottom. You will never skip all the way to one or the other. So there you go. It's the exact same sine wave. The only difference is we've shifted it down 1. So the next thing we're going to talk about is what we do with the b value. So the b value is known as your frequency. And this is how many times does it happen in 2 pi. So normally you go around the circle once every 2 pi. Well, if we change the b value, which again is our frequency, what that does is means every 2 pi we go around the circle twice now. So what that does is it changes your period. So to find your period, what we do is we take the period of a normal one and we divide it by the b value. So a normal sine or cosine wave is 2 pi, and we divide it by our b value, 2. So the period is now pi. And the pi will always go, or your period will always go on the 4th tick mark. And now we've talked about the interval as well. What are each of these other tick marks? Well, you divide the period by 4. So pi over 4 is just what we said, pi over 4. So this is now pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, and 4 pi over 4, which is pi. So whenever you have a b value, theoretically it does change what the graph is supposed to look like. But for our purpose, we're just going to scale the x tick marks accordingly. So positive sine still starts at the node and it goes up. Our amplitude is still 1. So if it helps you, draw a top and a bottom line. And this is what our graph would look like again. And of course you'd go backwards in the exact same pattern. So it looks the exact same. So what really happened here? Well, to show you what really happened, I'm going to go up to our original graph. Now remember, the blue one is the original sine. So what just happened is it completed one full cycle by the time it got to pi. So what happened was it actually looks like this. It made 2 complete cycles by the time it got to 2 pi. That's why the frequency is 2. So if we were to actually sketch these both out together, when you multiply it by 2, it's going to start repeating itself much faster. So if we were to say that was 8, it would be really skinny. If we were to call it 1/2, it would be much wider in terms of our wave. So that's what the b value does. But in terms of graphing by hand, the only thing we're going to do is scale the x-axis. Otherwise, it would be way too complicated to do if we had a big change in b. Finally, last example is going to cover a horizontal shift. Now this is a pi to the left, because it follows the same rules. When it's inside the parentheses, it's opposite of what you think. And since we do not have a change, we don't have a b value, this is still our 2 pi, this is still our pi over 2, and our 3 pi over 2. So how do we graph one of these? Well, there's a couple of different ways you can do it, but I'm going to show you my favorite way. And my favorite way to do these is to have a new starting point. So you obviously know the x-axis is our node. We have an amplitude of 1, so we're only going to go 1 above it and 1 below it. But now we have a pi to the left shift. What I like to do is draw a vertical line at that horizontal shift. So pi, as we see, is 2 tick marks, but we're going to the left, so 2 tick marks to the left. A positive cosine, as we've already learned, starts at the top of the graph. So now, if cosine starts at the top, we're just going to follow the pattern. Node, bottom, node, top, node, bottom. Going backwards, we're at the top, node, bottom. So this is the exact same cosine wave that we've already talked about. The only difference is it's now starting 2 units, or pi, to the left. Okay? again, our original one started over here. So as I mentioned before, all of these waves are going to look very similar, but a lot of it is going to be based on vertically stretching it. So it's going to have higher amplitudes, different frequencies. They're going to look different, especially if you were to graph them all on the same graph. But again, the red one is what the original one looked like. And the blue one just shows you that we shifted the starting point, which means every single point 2 tick marks to the left. So look, here's this point right here, 2 tick marks to the left. Here's our red one down at the bottom, 2 tick marks to the left. Here's our red one on top, 2 tick marks to the left. So we just shifted the entire graph left by pi. Okay? So again, that was a lengthy video because we had to talk about what each term does. The next video is going to cover multi-step. That's where we get to have a little bit of fun. This is Longo and I'm out. See you, bye.